This meeting is being recorded.
Everyone, so welcome to day 9 of Python class. So today we'll be discussing about tuples and sets in Python. Okay, so let me go to workbook here. Okay, so today we'll be discussing what are tuples and what are sets, how they are used in Python. Okay, so tuple is an immutable ordered collection of items. So you might have remember in our first day we learned about data types. So what are the various different data types? So we have mutable data types and immutable data types. So in mutable data types we have lists, and in immutable data type we have tuples, uh, integer and strings. Okay, so this is what we are learning today. Tuple. So what is tuple? It's an immutable ordered collection of elements. So what is the meaning of immutable? So once you have created a tuple, you cannot modify after you have created it. So it's an immutable. Second is it's an ordered collection of items. Okay, so it can store mixed data types. So like list, it can hold integers, floating point values, and strings in one single list. Similarly, even in tuple, it can hold mixed data types in one tuple. But the difference between list and tuple is list is mutable. You can modify list, but tuple you cannot modify it. Okay. So next we have we will see how to create a tuple. So just declare a variable, uh, and you can create a tuple using brackets. So these are the brackets that define this is a tuple. So let me make it little bigger. Yeah. Okay. So this is how we create a tuple. So why do we use tuples? It prevents accidental data modification. It's more memory efficient, and it can be used as dictionary keys. So we have another data type that is called dictionaries. So in dictionaries, we can use tuples as the keys of values. Okay, so we'll see that in another session. Okay, so next we have, so what are the kind of tuple operations we have? Okay, so let's see. So let's start with indexing. So even the indexing is same here. We saw indexing in strings, we saw indexing lists and in tuple. So they are all same in tuple also. So here you can see I'm trying to access the first element by calling its index. So this index of this tuple is 0. So this is 0, this is 1, this is 2. So when I'm saying my tuple of 0, so that means I'm accessing the number 1 from a tuple. So first element. So similarly, if I want to access second and third element, I can just mention I can access it through index, second element. So that's how we can access. So same thing. This is same thing as how we saw in strings, how we saw in lists. So the difference you have to understand here, strings are also immutable. You cannot modify strings. You can even if you replace one string with another string, the memory address will change. And in tuple, it strictly does not allow to change or modify a value in tuple. So we'll see that here in further details. So Here, even in tuples, we have indexing in positive and negative order. So see, the index starts from 0. So if you are counting indexes from the beginning, from forward order, so it starts from 0, 1, 2. Okay. So, and let me execute this, run this. Okay, so this is my forward indexing. If I execute these three statements, so this is my tuple. I have declared it. I have three items in my tuple. One is apple, banana, cherry. So I'm accessing the first element by calling its index, which is 0. I'm accessing second element by calling its index 1, third as second index number 2. So if I run all of them, I'll get all of them. So this is how I can access a tuple with its index. Same way, if I want to access a tuple from the reverse order, from backwards, so I can say minus 1 and my tuple of minus 1. So we'll be able to access the last element from a tuple. So like we saw slicing in string data types, list data types. Similarly, we have slicing in uh, tuples also. So we can slice a tuple. So it allows you to access a range of elements. So we have same way we have forward slicing and backward slicing. So if I want to do a forward slicing, index starts from 0. You can mention start and stop where you want to stop. And in slicing, we have one more uh, one more step called one more what about I can say one more uh, item called step. So apart from start stop, you can step also. You can write how many steps you want to take. You want to take one steps, two steps. So likewise, you can define that also in slicing. So this will be applicable to strings, lists as well as tuple. So let's see. I have a sample tuple. So it's letters A, B, C, D, E, F. Okay. So I'm doing a slicing. So whenever I'm doing a slicing, from start, I'm starting it from one. So where is my one here? So my index one is this one. So this is two, this is three, this is four, this is five. So this number, when I'm saying one, so it will start from here. It will go all the way till here. And since our end will be always n minus 1, it will stop here. So it will bring only these three values. So let me execute our first print statement here. Okay, so it will bring b, c, d. Now let's execute our second print statement. Okay, so I'm just saying 3. So what does this mean? Bring everything but stop at 3 minus 1. So n minus 1. So that means it will start begin from this letter A, B, C, and 3 minus 1 is 2. So it will bring all the way three letters. So this is how different ways we can access or slice a list. So we already seen this, but in terms of tuple, I'm showing you again how to do a slicing. So same way, we are starting it the index accessing from index 3 all the way whatever comes after 3. We are saying get all of those items. So let me run this DEF. Okay. Okay. Next we have print. So this is my start, uh, stop, step. So this is my step. So we are saying at a step of 2, for every 2 step, bring me what is the value. So I'm not defining what is my start. I'm not defining what is my end. What I'm just saying is take 2 steps, and when you take 2 steps, whatever the value you find, just bring me. So here you can see So first it started with A, then it take two steps, B, C. So after A, two steps will be C, then again D, two steps will be E. So here we don't have any step after this, so that's why it's not displaying this value. So that's how we can use steps. So in slicing, we'll have three options: start, stop, and step. Okay. So same way, like forward slicing, we have reverse slicing. So this uses negative step values, that is minus one. So we can see the same tuple. I'll copy it here. Okay. So if I say minus one, so what we are saying, start from minus one, go all the way, and it's actually a full reverse. So we already seen this in strings, how to do a reverse. We have seen this in uh, practice session, how to reverse a list. So same way we can reverse elements or items of a tuple in the reverse order by using this formula. You can say. So we are saying start from minus one and reverse, bring every letter in reverse order. Okay. So next we have what we are saying, accessing a tuple, and we are saying start from 4. So this is 0, 1, 2, 3, 4. So our 4 will be E, and what I'm saying is, uh, oh, okay, okay. Right. So in reverse order, our start will be here. Okay. So this is our start. So my start is here, uh, end, and step. Okay. So what I'm saying, start from F, step one letter, one letter, and stop till 4. 4. mm, mm. So from index 4 down to index 2. So where is my index 4? This is 0, 1, 2, 3, 4, and 5. So if I look at this in negative, so this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So this will be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. Okay. Okay. So from index 4, 4 to index 2. From 4 to 2, start in reverse order. So that's what we are saying. So reverse this index. So we have C, D, E, right? So what we are saying, bring reverse this items, bring E, D, and C. So that's what we are seeing with this formula here. So same way, there are a lot of ways we can slice and dice tuple. So same patterns we can access. We can do it in strings as well as in uh, lists also. So for tuples, here we can see If I'm running this command, let me comment this out. Okay. So my tuple of -2, my end, I'm not ending here. And I'm saying start from -2. So -2 will be E. I'm saying start from E, then step to negatively step two numbers. So it will skip this and go back to C. Again, what I'm saying, this is my step. So again, skip B and go back to A. So it's taking two steps in reverse order. So we can step in forward order as well as in reverse order also. So this is how slicing and dicing, slicing works in Python. So we can use slicing in strings, lists as well as tuples. Okay. Okay. So here are some techniques. What are the types of slicing we can do? It's a forward slicing, slice from start. These are all techniques we have seen. Partial slice, full reverse, step slicing. All these we can do. Okay. Okay. So next, we'll move. So what all we can do. So in this session, we are seeing what all we can do with tuple. Okay. So we can find the length of a tuple. So I have a tuple with three items. So I need to find the length. So I can use length function, len. So len is a function. This is a predefined function, predefined Python function. So we can use this function to grab this variable and put it inside, that will count the number of elements in a tuple. So this is what it's doing here. It's bringing the length of a tuple. So we have three elements inside our tuple. Okay. So let's say I have a nested tuple. So in the nested tuple, uh, so this is my zero. Combination of these two is my one. This is my this is at one index and this is at two index. So let's say I want to access just first element. So I will say nested, whatever the variable is. So I have declared the variable as nested. Instead of zero, I'll get one. So when I say nested of one, so when say index one, I get complete nested tuple. So we have a tuple inside a tuple. So this is the main tuple. Inside that tuple, we have a sub tuple. So I'm completely accessing this. Now let's say I don't want to access this complete tuple. I just want one value. So that I just want two from the subtuple. So what I'll say, again from this subtuple, if I define what are the indexes of this subtuple, so it will be 2 comma 3 would be again 0 and 1. So if I want to access 2, I'll say 1 and 0. Let me comment this. So this will bring me value 2. Okay. So similarly, if I want second element in the subtuple, I'll say 1. This is how it will work out. Okay. So this is about nested tuple. Okay. So we already talked about immutability. So this is very important concept. Like it will come handy when you are doing a problem solving. What type of data structure you are using, it will come in handy when you're doing a problem solving, because tuples does not allow modification of a tuple. So let's see an example. What I'm doing, I have defined a tuple. It has three items inside it, one apple and 3.14. So what I'm saying, I'm accessing this particular item, that is apple. I'm modifying it with banana. I'm trying to modifying it. So let's see what happens. So if I, so you can see it errors out. So what does it say? Type error. tuple object does not support item assignment. So by default, immutability in tuple does not allow modification of its items or its elements. Okay. Okay. So if you have any questions, you can come up or I can move forward with looping.
Questions.
Okay. Okay. Sure. So, like we have seen loops in previous classes, we can loop through the various values. Like we can loop through integer values, we can loop through string values. Similarly, we can loop through tuples. Okay, so a tuple is an ordered immutable collections. So what we can do, if we have a tuple with the three values, I can write for I can declare a variable item and say in my tuple. So what I'm doing is directly I'm accessing my tuple and looping through it and just displaying. So I can write a condition inside my loop. If item equal to apple, then only display it, something like that. So in those kind of scenarios, let's say I just know as of now I have only three elements in my tuple. Let's say tomorrow I have hundreds and thousands. So it will be a lot of manual work to find out whether my condition matches or not. So in those cases, I can use for loop, iterate through my tuple, and write my logic, and then print it. So this will be very much handy. So what I'm saying, this is my logic. So if item is apple, only then print it, otherwise not print it. So it will loop through all these values and then find out if it is apple, then print, otherwise it will exit. Okay. So similarly, there are other ways of accessing or looping a tuple. So we can use length function. So what does length function do? It will convert a tuple into integer. So whenever we use length function, okay. So this is my tuple. So let me, okay. So this is my tuple. So I'm just printing it. And if I say type, what type is it? So type will get what data type this particular variable is. So what data type it is of tuple. So now what happens when I convert my tuple in and get the length? So let's see what happens. So I'll say I'll declare a variable called n equal to. Okay, so let me first run it. So it might be okay. So let me first run this length of tuple. So how many elements I have? Three. So it got number three. So now I'll check the type of this. So it got converted to integer data type. Okay. So you can see we can convert our uh, the tuple length into an integer, and whenever we are using integer data types, we have to use range functions. So range function works only with integers. So that is the reason why we are using range in our for loops. Okay. So this is the range function that we are using. So this is how I can access the length of my tuple. Then I declare my for loop and I say for I in range of my tuple, print whatever the index, and then I'm accessing my tuple's value here. Okay, my tuple of I is, it will be 0, 1, 2. So all these values. So we are looping through our tuple. So this is another way of looping through a tuple. Then next, we can loop through a tuple using index and value. Okay, so by default, a tuple will generate both index and a value. So if we see here, so if I execute my tuple, this is what I get. So when I say enumerate, let me declare a variable, then print it, print a. Okay, so it stored everything as an object. Okay, so this enumerate function, it stored my tuple as an object. So this object will contain both index as well as value. So what I'm trying to do is I'm declaring two variables in my for loop, and I'm accessing those indexes as well as values from my uh, tuple. So when I'm saying enumerate, it will get both of them together. I'm just declaring these variables, so it will store index here and value here, and I will just print it here. That's it. Simple. So this is another way of looping through a a tuple data type using for loops. Okay. Similarly, we can loop in reverse order. Okay. So for item in reverse of my tuple. So what is my tuple? Apple, banana, cherry. So this is in forward order. Forward order. So it will just display everything in reverse order by using a reversed function. So this is inbuilt predefined function of Python. The same way, if I want to do the same thing manually, so I did it using Python internal function. But if I want to do it manually, I have to write using range functions. So in range function, I will define what is the length of my tuple, and I'll do a negative. Since I want to iterate from the end of the tuple, I'll say this is ending, and also say n minus 1. So whatever the number, take minus 1, then this is my n value, and this is my. So actually, if I say minus 1, it will add up. So this is how it is. So let me break it down so that it is clear. So length of tuple is 3. So if I say minus here, so it will become minus 3. And if I say minus here, uh, it will become minus 4. So our value here will be minus 4, because we maintain same values in negative integers. Here you can see, right? In the negative integer, we start with minus 1. Whatever the value is last, we say minus 6. We don't start with 0. That is the reason why we are doing this. We are adding up a minus 1 value with our n value. So our n value will become 4, and my start will be minus 1, and step will be minus 1. So I'm saying start at minus 1 from the ending, step each one of the values, and go till minus 4. So this is how minus 1 cherry, minus 2 banana, minus 3 apple. This is how it will be printed. Okay. Similarly, we can use while loop with index to loop through a tuple. So I'll define I equal to 0 while I less than length of my tuple, print my tuple of I. So this is where I'm accessing my tuple. Then I'm doing an increment here. So in while loop, it is compulsory. We should increment the values. By default, it will not increment the values. For loop, it will by default increment the values with plus 1. So that is the reason why we have to write this statement here explicitly. Okay. Okay, so this is how uh, we can use while loop with tuples. So let's say I have uh, nested tuples, a tuple inside a tuple. So I want to unpack these. So what I'm saying, this is my key, this is my value, key value pairs, combination of key value pairs I have. So what I'm saying, I want to unpack this and display on this format. So how I do is I can use for loop for key comma value in tuples. I can just say tuples and I can access this key. So all those keys will be stored in key variable. All these values will be stored in value variable. So first time when it runs, it will print a equal to a is key and one is value. Second time when the for loop runs, it will print b and b2. Third time c and 3. So this is how for loop will get executed. Okay, so these are the various ways we can loop through a tuple. So one more important function with tuples is we can return a value in a function. So we have seen function classes, right? So in function classes, whenever we have a function, we return a value to the caller. So when we call the function, so here, where is the calling happening? We are calling the function here. So whenever the function calling happens, this function will go here. It will check, okay, whatever the logic, it will calculate it. Then finally, it will return. Okay, so similarly, when I'm running this function, so it's returning the value x and x equal to 10, y equal to 20. So I'm getting those values and printing it here. Okay, so you can use tuples in functions to return multiple values. So let's say and right now I have one or two values. Let's say if you have 10, 20, 30 values, so you can, in those cases, you can use tuple. So that will be faster for getting values from functions. The same way, you can get stats from a list. Okay, so this is my tuple. So inside the tuple, I can have a list. So what I'm sorry, this is my function. So inside my function, I'm passing a list, and when I'm passing a list, I'm getting the result as a tuple. Okay, so here you can see this is my function, this is my logic actually, and this is my calling. So I'm calling here and I'm passing this value. Okay, I'm saying, hey, get stats functions, take this value 10, 20, 30. So what it will do, okay, get me number 10, 20, 30. We'll take these numbers, sum it up, and do average total divided by length of numbers. So total is 10, 20, 30, 30 plus 20 plus 10, 50, 60. 60 divided by 3 will do it. Then it will return. So here what we are doing, returning total comma average. So when it's returning the value, it will return in a tuple. Then again, we can unpack this tuple here. We can take those two variables and whatever the result that this get stats gets it, we can store it here, then again print it here. Okay, so most use cases are we can use tuples in for loops and in functions to get the values quickly. And same way, so I'm using a function check order even, passing a value, it will get me the value in uh, tuple. So what I'm doing, I'm unpacking here. So this is how it will work. Okay. Okay. So in short, what we can say, functions can return multiple values using tuples. You can access them by index or use unpacking. Great for returning group data like coordinates, stats, or multiple results. Okay. So if you write return AB, Python automatically wraps it in a tuple. So whenever we are writing this a comma b, right, return a comma b. So by default, function will understand that, okay, I need to return this value in a tuple data type. to the caller. So this is the caller, it will store it in this variable. So this is how default nature of a return function when we say x comma y. Okay. So this is about tuples. So we'll continue with sets. Uh, okay. So once this meeting gets ended, please rejoin. Okay. So even sets are immutable. So the only difference between sets and tuple is sets are unordered. So they are not ordered. They don't have indexes like tuples, strings, or lists. So the sets don't have indexes. And also, what are the features of sets? They are unordered and automatically it removes duplicates. So whenever you convert a data type to a set, automatically if there are any duplicates, it will remove it. And elements must be immutable. So even in sets, elements are immutable. Okay, so why we use sets? For faster membership tests. So if this value exists in this or those kind of operation, for mathematical operations also we use sets. So let's quickly create a set and print it. So this is my set. So you can see curly braces. So my set is have my set have curly braces. So now you notice I have one, two, three, two times three. But when I'm printing my set, it automatically removed one element, duplicate, and it printed just one, two, three. Okay. So what happens if you try to access a set like we do with?
This meeting is being recorded.
Okay. So what I was saying, um, what I was saying that we cannot access the set directly. So if I want to access set directly, I have to convert it to a list. Okay, so I can convert my set to a list using list function. Then I can access through a list. So what if I want to convert a list to a set? I can use set function. So set is a predefined Python function. Using that, I can convert my set to a list. Okay. So now we'll see what are the set operations. So what are the use cases of sets we saw? So we can use for fast membership tests and mathematical operations. So we might have read sets in mathematics, right? So in some of those chapters. So similarly, sets works in the same way. So if I want to add an element to a set, so I'll say my set dot add. So I'll mention what element do I want to add to my set. So I'm saying I want to add four elements. So I'll execute. So now my set has become of four elements. It has become a set of four elements. Now, if I want to remove one element from a set, I'll say my set dot remove. It will remove one element from a set. So if I want to do a membership test, so if this number exists in this set or not, so those kind of. So what I'm saying, three in set. So this means is three. Does three exist in set? So say is three in set. So it will answer in Boolean. So true or false. Yes. Now we have union operations. So these kind of union operations we will have in SQL also, and in mathematics also we have this. So if I want to union two sets, so the union will always bring unique. So what does union do? It will bring unique values only. So default operation of union is it will bring unique values only. So now I have one, two, three, three, four, five. So it should bring one, two, three, and should remove one more three and bring four, five. So if I execute set one, set two, and I'm saying set this symbol that you see, this is the meaning. This means we are doing a union operation. Okay, so this symbol denotes union operation. So you can see now we had two sets, set one, set two, 1, 2, 3, 3, 4, 5. But final result is 1, 2, 3, 4, 5. Okay. So similarly, we have intersection. So this concept we have in SQL as well as in mathematics also. So what does intersection means? Bring only the common values between two sets. So what are the common values? Three. And what else? We don't have anything. So it will just bring three. So here and denotes and symbol in sets denotes intersection. Okay. So next we have difference. So if I want to find the difference between two sets, so I can use minus set one minus set. So it has removed the it has calculated the difference. So next symmetric difference. So I have 1, 2, 3, 3, 4, 5. If I want to calculate 1, 2, 4, 5. So this is how these are all the mathematical operations we can perform in Python using sets. Okay. So let's see how do I loop through a set. So I can use for loops, right? So how do I use for loops? So I have my set here. So I have apple, banana, cherry. So notice we already discussed set does not have indexes. So if I want to uh, print, I can just print the item. I can just print the value. I cannot print index. Okay, so I cannot access individual item. Okay. So if I want to quickly compare between tuples and sets, so tuples are ordered, okay, while sets are not ordered, and tuples have indexing. So it will have forward index, reverse index, while set data types they don't have indexing. So tuples they will allow duplicates, while sets does not allow duplicates. It will always convert uh, if you convert a list or tuple to a set, it will make it a unique set. So all the duplicates will be removed. So we can loop through tuple as well as sets. And whenever we insert any value in a tuple, it preserves the order. But in set, there is no order. So it may insert the value at any place. So there is no order. There is order is not maintained in the sets. Okay. So we have some exercises. You can go through this, try to execute these programs and see like how you are able to work with tuples and how you are able to work with sets. Okay. So now I have a final comparison uh, chart here. So since we already learned list, we already learned tuple, we already learned set. So I have a final comparison chart to show what's the difference. How does it look? So this is how list looks like. So we have square brackets around it, and tuple we have brackets, just the brackets, and sets use curly braces, curly brackets. Okay. Now how do we create a list? We can just use this square brackets, or we can convert any of other data type to list using list function. Similarly, we can use open and close bracket to create a tuple, or we can use a tuple function to convert some other data type to tuple. And similarly, we can use open and close curly brackets to create a set, and we can convert another data type to set using set function. So these are predefined inbuilt functions in Python. These three functions are list, tuple, and set. Okay. So next, lists, they are mutable. You can modify an item from a list. You can replace 3 with 4. But in tuple, you cannot do that. It's not mutable. So it's immutable. And even sets are immutable. You cannot modify set actually. So let me check here quickly. Sets are also immutable. Okay. So list is ordered collection. So always list will be in it will be in order. So it will have an order indexes like 0, 1, 2, 3. If you are accessing in a forward direction, reverse direction -1. So even tuples will also have order, but set does not have order. List will allow duplicates, tuples will allow duplicates, sets does not allow duplicates. So you can do indexing with lists, it is supported, and with tuples also you can do indexing, but sets does not support indexing. You can do slicing as we have seen with list data type, and tuple data type also you can do slicing, but in list sets does not support slicing. Can access an element of a list by an index. Even for tuple, you can access an element of a tuple by index number, but you cannot access a set through an index. Okay, so you can have nested collections in a list, and also in tuple, and in sets also you can have nested collection if the elements are hashable. Okay, so hashable as dictionary key. So hashable keys, they are not allowed in list, but it's allowed in you can you can make tuple as a key for another values. You cannot make this sets as a keys for another values in nested. So if you have nesting of data types, which we will see in further classes. So iteration, we have seen for loops or while loops. You can iterate through a list, you can iterate through a loop, you can iterate through a set. You can find length of a list, you can find length of uh, a tuple, you can find length of a set. So what are the operations you can perform? These are the methods. In list we have append method, and since tuples are immutable data type, you cannot add. Once you created a tuple, you cannot add any other element inside a tuple. And here, uh, let me verify this set. Even sets are immutable. Even set, okay, yeah, sets. Even though sets are immutable, you can add. Uh, you can add a value inside a set. So let's check it here. Let's confirm it here. Set. Okay, so we have added a value to an to a set. We can add values to a set. Remove, you can remove element from a list. You can remove elements from a set, but you cannot remove an element from tuple. So this is the comparison. So you can do a membership test. You can do concatenation of lists. You can do concatenation of tuple, and you cannot do concatenation in the set. You can do some of the mathematical operations in sets. So if you want to do minimum maximum sorted, you can do with list and tuple, and also with sets. Math operations are not allowed on uh, lists directly, like union, intersection. In tuple also it's not allowed directly, but in sets it's allowed. So what are the built-in methods? These are the built-in methods in list: append, extend, remove, pops, insert, reverse, sort. And these are the built-in methods in tuple: count and index. These are the built-in methods in set: add, update, remove, discard, pop, clear. Okay. So conversion, how you can convert some other data type to a list using list function. And if you want to convert some other data type to a tuple, use tuple function. If you want to convert any other data type to a set, use set function. So this is how you can use. So finally, a quick recap. How does it look like? So this is a list, this is a tuple, and this is a set. Okay. So this is so far about tuples and sets. If you have any questions, you can come up, or otherwise we'll wind up this session. Okay, so we'll wind up. So if you have any questions, you can ask. We'll meet in tomorrow.